Arista Packets is a cloud-based network analysis and troubleshooting tool. It accepts packet captures from the user, processes them, and presents graphs, charts, and tables that summarize and analyze the data from the packet captures. This helps users to understand and troubleshoot network problems, especially the ones that can only be detected by packet-level analysis. Users can either simply visualize or also analyze a packet capture file. For example, a capture can be plotted in this way to display frame-wise details in an easy-to-understand visual format. This is one of the several visualizations that the tool offers for packet analysis. All packets are plotted in the form of bullets, and a tooltip carries additional information for each of these frames. In this case, the tooltip includes the reason for dissociation in this particular case, along with source MAC address, the time, and the frame number. This tool provides vendor-agnostic support for PCAP family of packet traces from almost any packet capture tool. Users can also store and organize their packet captures here for easy and quick access. By caching traces, packets significantly speeds up trace interaction and avoids time wastage in loading and filtering of large trace files. This tool also helps in collaborative troubleshooting. Users can tag specific parts of a trace with notes and share them within an organization, especially valid for enterprise users of packets. Users can also capture a packet trace using an Arista AP at any remote site and have the trace directly uploaded and visualized in this tool here. Packets is a 100% cloud-based tool. Apart from the frame-wise view of the packet capture, there are many useful charts to capture various statistics. These dashboards here present a breakout of various kinds of frames, such as data frames, management frames, control frames, the client throughput, and so on. On this dashboard snapshot here, you can see the data frame versus management frame distribution. Within the management frames, this maximum part of the management frame is dominated by beacon frames, which are nearly 87% here. Apart from the beacon frame distribution, you can see the percentage distribution of probe frames, authorization, association, and dissociation frames in this chart here. Similarly, other charts show you distribution of unicast, multicast, broadcast frames, top clients by their distribution, top clients by percentage retransmissions, etc. All these statistics enable a mechanism for quick health check of a network for the duration of the packet capture. The maximum size of the trace file that can be uploaded to packets is 100 MB. If the file size goes higher than 100 MB, users can choose to filter out data packets when debugging connectivity issues through Wireshark. For example, for performance-related issues, the payload of data packets can be removed, keeping only the headers for troubleshooting. This ensures that the trace file that is to be uploaded is within 100 MB. Apart from this, within the tool itself, there are additional filters while viewing a trace file so that users can filter out unnecessary frames and do focused troubleshooting. In this case, for connectivity troubleshooting, users can choose to completely filter out the data frames and focus on other kinds of frames. Let us now look at the packets interface and analyze a PCAP file. The packets landing page here displays all the packet capture files a user has uploaded in the past. We will open this packet capture file. The Analyze dashboard here gives insights into performance, connectivity, and connected clients and access points, along with a frames view. The performance section shows a data rate timeline, as well as information on the client health, average connection latency for clients, and distribution of different kinds of frames across the clients and the access points. As you can see here, there are 8 unhealthy clients. These are all clients with RSSI less than -70 dBm or link speed less than 20 Mbps. The average connection latency chart here shows that this particular client has faced a far higher connection time compared to this client. This bar shows the details of the breakout during the connection phase, the association latency, EAP latency, and the ePOL latency. A network admin can see the total retransmissions across all clients in this chart. The chart brings out distribution of retransmissions between data, control, and management frames. The airtime distribution between different frame types in this chart shows that management frames are approximately 54.09%, control frames constitute approximately 29%, and data frames constitute approximately 16.22%. Further, there is breakout of the management frame distribution and a control frame distribution, as well as a distribution of unicast, multicast, and broadcast frames. Apart from this frame related information, this performance section also shows clients with lowest average data rates while sending and receiving, as well as clients with lowest average RSSI and top clients by percent retransmissions. To see the connectivity status of clients and troubleshoot connection issues, if any, being faced by the clients, we will now go over to the connectivity section. This section provides insights into client connectivity timeline, along with types of connectivity failures, top clients by connectivity failures, and details of frame exchanges between clients and access points. This timeline here shows the journey of a client that faced connectivity issues. This client has faced several connectivity issues such as authentication failure, association failure, DHCP failure. This chart here shows us that there are 57% association failures along with DHCP failures, disconnections, and authentication failures. The top clients by connectivity failures chart shows that this particular client, 66A9F0, as the ending part of the MAC address, has faced a lot of connectivity failures. There are a total of 300 kinds of connectivity failures that it has experienced. Out of those, 21 are disconnections, 13 are authentication failures, there are 97 DHCP failures, and there are 178 association failures. Let us troubleshoot and see why this client is facing so many issues. Going back to the client connectivity timeline, we see that this is the same client here. We will now drill down into the client to see details of packets exchanged between this client and the connecting access point. This table here shows that all the details between the frames exchanged between the client and access point, along with the channel used and the connection end reason. The connection end reasons here are different kinds such as association failure, DHCP failure, disconnections. To further troubleshoot what is happening with this client, user can now click on the client MAC address. You will now be taken to the visualization section of the packets tool. The visualization of this PCAP file displays details of the frame type against the frame number. All different kinds of frame types are plotted on the y-axis here. A handy tooltip provides more information such as the frame type, the source or destination MAC address, timestamp, and other relevant details depending on the kind of frame it is tagging. There are additional views to see the data rate as well as the frame size during troubleshooting. So users or network admins can use this information to correlate. For our case here, we will go back to the frame view and focus on the connectivity troubleshooting. The frame filter here makes it possible to do focused troubleshooting for a network admin. Now, to see connectivity related issues in this capture, we will simply filter out all the data frames. This gives us a much cleaner view of the frame capture, and only relevant details required for troubleshooting are displayed here. As you can see, this capture here shows that there are a lot of deauthentication frames that this client has been receiving. The tooltip displays that the source address of this deauthentication frame is the address ending 30F07D. This is in fact the access point that the client was trying to connect to. This means that the access point is sending multiple deauthentication frames to this client. What this may mean is that this is actually a rogue client It has been identified as a rogue by the Arista intrusion prevention policy that is applied to the AP. And hence the AP is quarantining this client. That is, it is not allowing this client to connect to an authorized network by sending deauthentication frames. Thus, it is now clear that this is a rogue client that is being prevented. Going back to the analyze view, apart from this connectivity related dashboard that we use for troubleshooting, there are additional views that capture the list of clients and participating access points. Users can similarly drill down onto any MAC address of a client or AP to gain detailed visualization and do further troubleshooting depending on what the use case is. So this is an overview of the Arista Packets tool. To access this tool, simply use your Arista SSO credentials. This tool is available for free to all Arista customers. For non-Arista customers, simply sign up at packets.arista.com. This is a free web tool and accessible to everybody.